All right, derivatives of inverse trigonometric functions. Guys, if at any time that you're struggling, please stop me and ask me the question, because this is a lot of review condensed in a short amount of time. And depending on how far you went with your pre-calc class with this and how much you memorized it then will dictate how much you have to catch up now. So in pre-calculus, you learn two notations of inverse trig functions. The inverse of cosine can be symbolized as arc cosine or arc cosine, just two different ways. Okay, and this is the inverse of sine. A lot of people mistakenly think that the inverse is a reciprocal, and they think the inverse of cosine looks like that, but that's not correct, because this is secant, and the inverse of cosine is one of these. You with me? So which word do we associate with that instead of inverse? Reciprocal. Know the difference, please. So the reciprocal of cosine is secant. Are we good? Okay. Here we go. Now it's been a minute since we've done these, and the three that I want you to concentrate more on right now, because there's a lot, are the cosine one, the sine, and the tangent. I know it's been a minute since we've done these, but looking at this, if you can understand how these relate to their inverse functions, it's easy to remember that arc cosine is from 0 to pi. And it's easy to remember that arc sine and arc tangent are from negative pi over 2 to pi over 2. So this right here is the unit circle representation. Whereas this is like the Cartesian, like the coordinate, the xy coordinate plane.
Can you explain to me why those are the values of the circle?
Yeah. So looking at this, we started today's notes by looking at the convex translated one to the right square root function that Rovik was talking about, and the x squared plus 1 that Jordy was talking about. And it all depended upon which one was the original and which one was the inverse. So you with me? So where the original one that was given passes the horizontal line test will dictate where the inverse will pass the vertical line test, vice versa. So on these over here, watch, I'm trying to see where would the range exist on the inverse of cosine. So that means on the original one, I have to see where would it pass the horizontal line test. So from 0 all the way to pi is where the original one would pass the horizontal line test, which means where the inverse would pass the vertical line test. Let's go back to sine. That from negative pi over 2 to pi over 2 is where the original would pass the horizontal line test, not the vertical one, but the horizontal line test. So therefore, that is where the range will be for arc sine. And the same thing, where does it pass the horizontal line test? That will dictate where this one's range will pass the vertical line test. Does that make sense? Okay. Any questions? So guys, when you are given sometimes to solve for x and solve problems, they domain restrict you, and it will look something like, okay, that the theta is going to exist between 0 and 2 pi, either including 2 pi or not including 2 pi. And a lot of times they just put x instead of the theta. But you know this notation that I'm talking about, right? It's restricting it. We did one of them today. But what if it doesn't? If it doesn't give you that, you have to remember that arc cosine is 0 to pi, and arc sine and arc tangent are negative pi over 2 to pi over 2. So again, this is review. So let's go to our problems. Notice how there's no domain restriction or range restriction. Arc sine is going to give you an angle. So notice the progression. Sine deals with y values. And I'm looking for what angles did a negative y value of 1/2 come from. So if I drew like the unit circle, the negative y values are here. You with me? And right now, a negative 1/2 could be, so 3, 2, 1, 3, 2, 1. It could be here or here. So what angle is this, guys, normally? 11 pi over 6. Good speed. Which one is it? 7 pi over 6. But is it any one of these answers, yes or no? It's not. Because I have to remember just now from the notes that we were talking about with Christian, is that the arc sine is looking specifically between negative pi over 2 and pi over 2. Which means it's got to be this one. But we're not going to call it 11 pi over 6. We're not, because we have to be in between a negative pi over 2, bless you, and pi over 2. So we're going to think of a coterminal angle that exists somewhere here. Anyone, what is it? Negative pi over 6. Negative pi over 6 is how you're going to answer this. Because a negative pi over 6 is about right here. But if you said 11 pi over 6, that's way over here. And it's not in that range that we were talking about. Questions? Okay, so again, this is review. Let's do one more. We're looking for where does arc cosine yield a negative root 2 over 2. Notice the progression. Here we go. Arc cosine, and I'm looking at unit circle, is when the x, because it's cosine, is negative. So I'm looking at quadrants 2 and 3. And I know, because it didn't say a certain range like 0 to 2 pi, that I have memorized the arc cosine's range is from 0 to pi over 2. So where's my overlap? 3 pi over 4. Right here in quadrant 2 is where I'm going to be looking for this. And I want to know, when is the x value a negative root 2 over 2? This is why we wanted you to memorize the unit circle so quickly, because the recall of this to the level, it has to be like quick. So this is going to be 3 pi over 2. Sorry, 3 pi over 4. Is 3 pi over 4 between 0 and pi? Yeah, so we don't have to come up with a clever coterminal angle. There's the answer for that one.
So how would you do the arctangent one? Like,
Oh, don't worry about this one. This one's using a calculator. So we're not going to do that one. Is that what you were going to ask?
no, just to clarify, the reason you got to that is you saw that, like the green part, it's to the left of the y-axis because of the negative.
Yep.
Because it's arc cosine that it was at the top, so you singled out that.
Perfect.
Okay.
Perfect. Okay, so here we go. Now, it's been a while since we've done this one. But we're looking now at finding the sine of the arc cosine of 4/5, the sine of the arc cosine of x, the secant of the arc tangent of 3x. A little bit of review. When we did this, we found reference angles. And we found reference triangles is a fast and efficient way to solve these kinds of problems. Guys, what kind of value does arc cosine of 4/5 give? Oh, okay, maybe you're going straight to the, okay, you're going straight to the answer. The arc of any trigonometric, arc cosine, arc sine, arc tangent, they all spit out what kind of value? An angle. An angle. So this right here, I want you to look at this as theta. All of this is theta. And all of this is theta. Okay, here we go. Arc cosine. Cosine we know is adjacent over hypotenuse. Says that from here, this is the adjacent over the 5 hypotenuse. This is over what? An understood 1. And cosine here is adjacent over hypotenuse, adjacent over hypotenuse. You see how I'm doing this? And I'm kind of wanting to do all three of them at the same time. This is 3x over 1. But tangent, what is tangent? It's opposite over adjacent. So 3x goes here, adjacent goes there. And the reason why we do this is so that we can find the missing pieces. Using what? Pythagorean theorem, right? Pythagorean theorem. What's the missing piece for the first one? 3. And you got that from c squared minus b squared, and then take the square root. And that can give you a. Go with me? Or you remember the Pythagorean triple, 3, 4, 5. Let's come over here. What would the missing piece be here? The square root of 1 minus x squared. Just Pythagorean theorem, right? What would the missing piece be here? The square root. Ooh, nice. 1 plus 9x squared. Because b squared is 9x squared. Okay? You need to let that sink for a little bit. So now, all I'm going to do is find, what is the sine of theta? What is it? 3/5, opposite over hypotenuse. What is the sine of theta? That stuff over 1. Because it's the opposite over the hypotenuse. We never even have to find theta. It's like we're using it as a median in between to find my trigonometric ratio of what I'm looking for. So secant of theta. First of all, secant is the what of what? Reciprocal of cosine. So cosine is the adjacent over the hypotenuse. So if I reciprocate that, it's the hypotenuse over the adjacent. So this is just going to be the square root of 1 plus 9x squared all over 1. Easy, right? This is not bad at all. Now let me finish it off with one problem of the new stuff that we're talking about, okay? You're going to learn one of the differential rules of one of the inverse trig functions right now, okay? Let's look at this one right here. Our goal is to find what dy dx equals. Our goal is to find out, I'm going to rewrite this, what is the derivative rule of inverse sine or arc sine?
Can we treat it like sine squared? You know, like use power rule, chain rule.
You can't. No, you can't think of it like power rule. Not on this one. So what I'm going to do is, check this out. I'm going to take the sine of both sides. Okay? Again, all this is asking for is theta. Guys, listen. All of this is theta. They've just named it y. Okay? But it's still theta. I know it's a little weird. They're just naming it y. And your goal is to find the derivative, the dy dx. So let's go for it. If I differentiate both sides right now from the implicit differentiation that we just learned, what's the derivative of the left? Cosine of y times dy dx. And this is what we're looking for. Is equal to what? 1. So now, the derivative, which is what we were looking for, is just equal to 1 over the cosine of y. So, here we go. Arc sine of theta. Said sine is opposite over hypotenuse. X over an understood 1. What is the missing piece here? Using Pythagorean theorem. 1 minus x squared square rooted. So if I said, what is the cosine from y? You would say the adjacent of the hypotenuse, which is going to be just this over 1, right? So we're going to put that all right here so that the derivative rule for arc sine, I'll just put it right here. The derivative rule of arc sine is 1 over the square root of 1 minus x squared.
Would you want us to rationalize that?
Nope, that's perfect. And that's one of the first of 6 that you're going to memorize. Yeah, I know. Next class, we will finish these off. We will practice, and then we will review for the rest of the period. And then your test is in 2 classes from now.